So,
Okay.
kind of like what we did last time.
Cool. Yeah.
How'd you do on the homework? Did you have any problems with any of it?
I just had problems on a couple of them.
Okay, let me bring it up here.
Sure. It was on page 138, number 7.
Okay. What we have is parallel lines and a transversal.
Okay.
Okay, and that's the key thing to recognize in all of these. It's unbelievable how many problems you're going to have to solve based on parallel lines and transversals.
Okay.
Okay, now it works both ways. By that I mean if I have two parallel lines and a transversal, then I know that 1 is equal to 2, and that 3 is equal to 2.
Yeah.
Well, it works, like I said, both ways. If the information you're given is that 2 is equal to 3, then that means those lines are parallel, even if you didn't know they were. There's no way that angle 2 can be equal to angle 3 without the two lines being parallel.
Okay, that makes sense.
That's what I mean when I say it works both ways. Now, so here, what they're saying is that x equals y.
Yeah.
Let me think about that for a second. And they're telling us that's a right angle, so y has to be what?
So y has to be 90 degrees.
And x has to be
90 degrees.
So is line 2 parallel to line 3?
No. Yeah. It's perpendicular. Oh, it is?
Yeah, 2 and 3 are the two vertical lines.
Oh, yeah. I was looking at the wrong one. Yeah.
So, yes, that means they're parallel because of these angles being equal to one another.
Yeah.
Now, is line 1 perpendicular to line 2?
Yeah, it looks like it.
Yes, it is.
Yeah.
In other words, if that's a right angle, then that's a right angle, and they told us x was equal to y, so that's a right angle. So the fact that x is a right angle or 90 degrees means they're perpendicular.
Cool.
Any line that intersects line 1 also intersects line 2.
Okay. Any line that intersects line 1 also intersects. Yeah, that's correct.
Actually not. Look at line 3.
Line 3, yeah. Well,
line 3 intersects line 1, but it's parallel to line 2. We just proved that.
Yeah.
Two lines that are parallel will never intersect.
Okay.
Okay. So this statement 3 is not true. So only 1 and 2.
Okay.
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 And on 139 also you had, or?
Yeah, let me see which one it was.
Kind of the advanced page. You're doing the odds.
Yeah, I think it was number 11, which I was confused on.
Okay.
Just following.
Here's the thing. I would love to cover most of this material. We only have an hour and a half more.
Okay.
So what I kind of decided was that I wouldn't cover the advanced.
Oh, okay.
Because it's not just angles, that's not the only, what's coming up next is triangles and then circles and then quadrilaterals, and each one of them has a basic, an intermediate, and an advanced.
Yeah.
And I think as far as you are concerned, we probably should not spend time on the advanced.
Okay.
Only because we've got to draw a line somewhere, and I'd rather cover more of the subject matter than get deeper into each subject.
Yeah, definitely.
I made a mistake by giving you this one and covering this one. Well, not a mistake.
It's okay.
I started thinking about it and realized we were going to run out of time long before we ran out of problems.
Gotcha.
So today we'll just do, this is the basic, and then there's an intermediate. But this is the triangles test. And then what's coming up next is the circles test, and then the quadrilaterals test. These are the things, the basic stuff you really need to know. So we'll stick with doing the evens in our section, but we won't do the advanced.
Okay.
What's angle X?
And number 2?
Uh-huh.
Okay. So 60. It would be the first one, 120.
Good. No. Does it look like 120?
Oh, no, it doesn't. It's less than 90.
Hold on, but your arithmetic was correct, but what you came up with was that angle right there.
Yeah, not X.
Okay, but if that angle is 120, which is correct, what is X?
So you do 180 minus 120 to find X.
Right.
And then, so that would get you 60. That would get you 60.
Get a calculator in front of you if you don't have one.
Okay, yeah, here I got one.
I mean, I would, if we had all the time in the world, I would say do not have a calculator in front of you. But we don't want to spend time on arithmetic here. We want to make sure you understand the principle. So that's 120, that's 60. Notice that that is the same as that plus that. So
it is, yeah.
It actually is an exterior angle theorem that says that an exterior angle of any triangle is equal to the sum of the two angles that it is not a linear pair with.
Okay.
Okay, so no matter how I draw the triangle, this angle is always going to be the sum of that angle plus that angle.
Okay, that makes sense.
That's a good one to memorize, although you can always work it out like you did. In other words, you knew that 20 plus 40 is 60, therefore this one had to be 120, and now you can figure that out. But save a couple of steps by memorizing that theorem.
Okay, yeah, definitely.
But number 4.
Okay, so an ABC above X equals... Well, so you would just add 55 plus 30 together and then subtract that from 180 to find X.
No,
is that right?
Would give you X. That would give you that angle there.
Oh, that's, yeah. What? How would you...
Notice we have 3 triangles. We have this one, we have this one, and we have the big one.
Yeah.
Start with the big one.
Okay.
Now,
so, so we would do...
If that's 50 and that's 30, what is angle ABC?
So that's 80, so...
No.
180...
It's 100.
50... So it'd be, 50 plus 30 and then subtract that from 180.
Exactly. Remember how I said that the most important skill you can have in geometry is the ability to subtract from 180? Almost every single problem has that.
Okay. Yeah.
So don't make your mistakes there. So what is angle ABC?
ABC, well, it's one, it all adds up to 180. So...
Or angle B, if you like. What's this big angle right here? That's the third angle of a triangle. Just add these two and subtract from 180, and you got it.
100.
Okay. Now, if that whole angle is 100, what's X?
50. Well, no. If it's... Okay, so if it's 100... and that's 55, then that would have to be...
Get your calculator.
That's 45.
Okay, get your calculator out. Let's not spend time doing those kind of problems. In other words, Just do 100 minus 55. That's what gives you x.
Okay, yeah. I'm sorry, yeah. I just got a little confused there.
And let's see.
Okay.
We want to do 6 and 7. This is still basic.
Okay.
Okay, hold on. Let me blow it up a little bit.
Sure.
All right. So number 6.
Okay, so what is the measure of PTR?
Which is this angle right there.
Okay. So let's see here. That would be.
Excuse me. I told you wrong. It's not that angle. It's PTR. In other words, it's that full angle right
there. Okay. Oh, okay. All right.
Okay.
Okay.
So
that would
make sure which triangle you're going to look at. There's 3 triangles there.
Yeah.
Which one do we want to focus on?
Well, we want to focus on
the big one.
Yeah, the big one, yeah.
Right? Because they're asking about PTR. That's an angle in the big triangle. It's not an angle in the 2 smaller triangles.
Yeah.
So, if we're going to focus on triangle PTR, let's see if we can find out what all the angles are. Well, we know this one. Do we know this one here?
Yeah, 180 minus 140 would get you that one.
What is it? Give me a number.
40.
Okay. Now, if that one's 40 and that one's 50, what is PTR?
90.
Good.
Cool.
Number 8. What is x in terms of y? Well, the easiest way to answer these kind of questions is to what equation can you write regarding x and y?
We could do 30 plus x plus y is equal to 180.
Okay, so I'm going to write, I'll write it the way you said it. 30 plus x plus y is equal to 180. And they want to know what is x, so let's solve for x.
Okay. So what we just do 180 minus 30 to find x?
Okay, so
no?
Now that gives us x plus y.
Uh-huh.
In other words, I subtracted 30 from both sides.
Mm-hmm. And then we would subtract x from both sides.
Now we're solving for x.
Oh, that's right. So we would subtract y from both sides.
So there's the y there. There's the y there. This is our answer.
Yeah, 150.
In other words, once you can structure it as a simple equation, it's usually pretty easy to come up with the answer. The secret in geometry really is always attempt to be writing an equation.
Okay.
Okay?
Yeah.
It's kind of like when you're solving word problems, the first step is always define your variables.
Uh-huh.
And once you do that, the rest of it kind of falls into place.
Okay, that makes sense.
Still the basic part, number 10.
Okay. So to find x, we would do x plus 20 plus x plus 20 plus 30 is equal to 180.
Good. I was going to say, look for an equation that you can write.
Okay.
Once you can find that equation, then you can solve it.
Uh-huh.
Next line?
Next line would be 2x plus 50 is equal to 180.
Next line?
And then it would be 2x is equal to 130.
And the last line?
And then the next line would be 2.
Where's your calculator?
Yeah, I'm doing it right now. Divided by 2. Alright, 65.
Okay. In other words, you can get by depending on that calculator, probably.
Yeah.
You get to use it, don't you, on all your tests and stuff?
Yeah.
You ever not get to use it?
No, hardly ever.
So,
Yeah.
what you want to do is get good at using it.
Okay.
It shouldn't take you 20 seconds to do that problem. It should take you about 5 seconds.
Yeah, it was weird. Like, I put it in and then it just came out as 0, so I don't know what happened.
Okay, well, part of the secret for you is going to be figuring out how to use that calculator properly.
Yeah.
In other words, if you consistently are trying to do that, you're doing something wrong, and you need to figure out what it is. Okay?
Okay.
Like I said, you can succeed in math doing all of these with a calculator. I would prefer to see you doing them manually, but not if it takes too much time.
Yeah.
In other words, it comes down to speed, and in terms of speed, you just need to do that quickly.
Okay.
Okay?
Yeah.
Number 12.
Okay. So again, we could just do x plus y plus 140 is equal to... Actually, I don't think we can do that for this one.
So, again, our goal is to write an equation. But
Yeah.
they're exterior angles.
Okay. Not interior.
They're not interior angles. However, we could, we know what that one is. What's that one?
40.
Okay.
So we know that one's 40.
This one's 180 minus x, and this one's 180 minus y.
Yeah.
So, that's one way to do it. I'm not sure that that's what we want to do, but let's try that. And I'm going to put parentheses here.
Okay.
And even though I really don't need to use parentheses, those three angles should equal 180, right? The reason I said I don't really need to use parentheses is because these are plus signs here.
Yeah, exactly.
If those were minus signs, I would need to use parentheses. So I tend to always err on the side of caution and use parentheses. But now when I look at the problem, I can tell that I can just erase the parentheses and everything's fine.
Okay.
Okay? And you see why I can do that. I can erase them because when I distribute these plus signs to each of these terms, it doesn't change their sign at all.
No.
Okay? So now, what's the next best step? Remember, we're trying to solve for not x, not y, but
x plus y. Yeah.
How are we going to get x plus y all by itself on one side of this equation?
Well, first of all, we could subtract subtract 40 from both sides.
Well, let's first of all subtract the 180 from both sides, which makes it more simple.
Oh, that is, yeah.
I'll always do the simple stuff.
Yeah.
But make sure that you know that you're subtracting, which means you're leaving 0, as opposed to dividing, which would leave 1. So they're not the same always, but in this case we're subtracting, so I've left 0. Now how am I going to get x plus y on one side of the equation only?
We could subtract 40 from both sides. So we get, negative x, Okay. And then we would subtract 180 from both sides.
What's that leave me?
Negative x minus y is equal to negative 220.
Okay. Now what?
And then Let's see. Well, they're negative, but we have to get them positive. How would we get them positive? Just...
Well, we could divide both sides by -1.
Okay.
When I divide the left side by -1, it becomes this. And when I divide the right side by -1, it becomes that.
Okay.
However,
and then that's our answer.
Let's go back.
Okay.
You did a couple of things here that I don't like. First of all, you subtracted 40 from both sides.
Mm-hmm.
And our goal at this stage of the game is to get our x plus y on one side of the equation and get our numbers on the other.
Okay.
So the better way to view this is let's combine the 40 and the 180 and get it on the opposite side of the x and the y.
Okay.
But notice there's a couple ways to do that. In other words, what if we just add x plus y to the left side of the equation? In other words, add an x and add a y. Here's what we get on the other side. And we lose that, and we lose that. And now we get the thing immediately. X plus y equals 220. So,
which saves a step,
It saves a step, but more importantly, it illustrates an important principle when you're solving equations.
Okay.
Try to get positive coefficients.
Okay.
Okay? When I'm at this stage of the equation, I got negative coefficient, negative coefficient. If I move both numbers to the right side, I'm going to have 3 negative coefficients. So my thought process really should be, how do I get x plus y? Well, what if I add x and add y to both sides of the equation? I'm going to have x plus y. And that's the way we should be thinking.
Okay.
You always have two choices when you're solving an equation. You can move, but the most important thing is you got to get the variable on one side, the numbers on the other. Or if you're solving for two variables, get them on one side, get all the numbers on the other. That's the thought process you want to focus on.
Okay.
Okay? It's not just going through one by one and moving that to the other side. And that's kind of what you did. You kind of want to view it as, how am I going to get to the final solution the quickest? How am I going to get x plus y? As opposed to just picking this thing apart piecemeal and doing it that way.
Okay.
All right. Let's see. 152.
Okay.
Now, okay, this is intermediate, so these are going to be a little tougher, but not doable.
All right.
Primarily, keep in mind with geometry that when you have a figure like this, there is no way we're solving for that in one step.
No.
It's impossible.
Yeah.
So we're going to have to solve for other things first. Just know that.
Okay.
That's a good thing to know, because if you get stuck on just trying to solve that all by itself, you don't go anywhere. Whereas if you start solving for other things first, you can go places.
Okay.
Now, is that barking on your end or mine?
I don't know.
It might be hard. I hear a dog barking, and I'm wondering whether I should open my door and go find out what's wrong with my dog. But then I think I heard it on your end.
I don't know. I don't hear my dog. I think is Jenna, is Aston sleeping or?
Hold on a second.
Oh yeah, our dog is sleeping, so.
Hi. Hi. All right, stay out there. Yeah, it was my dog. I just don't know what she was barking at. But
no problem.
Okay, so they want to know about that. Well, we know that angle. If we knew this angle here, we would know. We'd be able to figure that out.
Yeah. All right.
We can't figure that one out immediately, though. Oh, I forgot to read this. AD is parallel to BC, which is interesting because they have not drawn it that way. If you'll notice, those two lines are not parallel, and I almost didn't read it. And I'm sitting here struggling. How in the heck are we going to figure this answer out?
Yeah.
Knowing that AD is parallel to BC, that solves everything.
Awesome.
Okay, so which angle should we figure out first?
Well, we know that in the small triangle they're all 60.
No, we don't. Well, are you talking about this triangle?
Yeah, we know that one.
That's 70.
Oh, that's yeah. So it would be 30. So that one would be 30.
Hold on. That's why I say you want to get good at subtracting from 180. And if you're not going to be 100%, use your calculator every time.
Okay, so it's 180 minus 130. So it'd be 50.
Okay, and then if that's 50, what's that?
Oh, then that's 50.
And if that's 50, what's that?
That would be 110. 180 minus 110, so it'd be 70.
Okay, and if that's 70, what's that?
And then you do 180 minus 70, and then that'll get you...
Remember, we have parallel lines. This is parallel to that. That's a transversal.
So that would be 70 as well. X would be.
Right. In other words, here's our situation. We have parallel lines like that.
Mm-hmm.
And we've figured out that that's 70.
Okay.
Because these lines are parallel, this has to also be 70.
Yeah.
Remember that when you're dealing with parallel lines, either this angle is supplementary or it's equal. That's the only possibility.
Okay.
Now, I know that they want you to memorize alternative interior and alternative exterior, but none of that really matters as long as you understand that when you're dealing with parallel lines and a transversal, either the angles are equal to one another or they are supplementary to one another. Well, if you look at these two, that's an acute angle.
Yeah.
Well, I can tell that's not an obtuse angle, so this has to be equal to that.
Yeah.
Because they're both acute.
Uh-huh.
All right.
Okay.
And I screwed up. I did an odd one.
That's all right.
All right.
14?
We'll do 14 next. Yeah, I won't mix it up, but there you go. You got one that's already done for your homework.
All right.
All right, here.
Which of the following must be true?
So we have three angles of the triangle that are defined as a function of x, and then we have one of the sides that's defined.
Yeah.
So, looking at number one, x is greater than 50, it's clear we're going to have to figure out what x is.
Yeah, for sure.
So how do we figure out what x is?
Just x plus x minus 15 is equal to 180.
So what's the next line?
3x minus 15 is equal to 180.
And the next line?
3x is equal to 195.
Oh, excuse me, my mistake. So,
no, it's okay.
Sorry.
It's all right. And then the next line would be x equals 65.
Okay. So number one is true.
Uh-huh.
Now, we have a triangle whose angles are 65, 65, and what's this one?
And then that one would be 50. Wait, yeah, 50.
Correct. And this side is 10. And this is A, C,
Okay.
So, is AC less than 10?
Huh? We don't know, do we?
Actually, we do. And this is a principle you may not have gotten yet, but let's talk about.
Okay.
Whenever you have a triangle, the longest side of the triangle has to be opposite the biggest angle, and the shortest side of the triangle has to be opposite the smallest angle.
Okay.
Okay? So if this side is 10 opposite a 65-degree angle, well, the first thing we know is that's also 10.
Yeah.
And the next thing we know is that this side has to be less than 10.
So 8, yeah, so
Because
B.
it's opposite the 50-degree angle.
Yeah.
So I don't know what that side is, but I know it's less than 10. It can't be greater than 10 by definition of triangles.
Yeah.
Okay? So,
Okay.
AC is less than 10 is a true statement.
So 1 and 2 are correct.
Yeah, and AB we can see is not greater than 10, it's equal to 10.
Yeah, so it'd have to be 1 and 2 only.
1 and 2 only again.
Yeah. Okay. Alright, what is the length of a hypotenuse of an isosceles right triangle of area 32?
Okay.
Okay.
First of all, let's draw it.
Yeah.
And that's equal to that. In other words, whenever you have an isosceles right triangle, it's always the two short sides that are equal to one another. You're never going to have the hypotenuse equal, because the hypotenuse is always opposite the 90-degree angle.
Okay.
It's always the longest side of the right triangle and never equal to one of the short sides.
Okay.
Okay? And they want to know, they're telling us what the area is, so let's start with the general formula for area.
Alright, area is equal to base times height divided by 2.
Okay. And they give us the area, so I can fill in 32. What else do we know about base and height?
We know that they're equal to each other.
Okay, so let's, instead of calling this H, let's call it B again.
Okay.
Okay.
Yeah.
And then what should the next line be? If I know the area is 32, tell me what the next line I should write is.
Let's see here. So we know the area is 32. So we
fill in
8 times 4.
Hold on. Fill in for area. Let's start there.
Okay, so it would be area is equal to, 32 is equal to 1/2 base times base.
What's base times base equal to?
1/2. Well.
Base squared.
Oh, base squared. Yeah. Because Okay.
Okay.
Because base times base. Yeah.
Now what's the next step?
Now we would. Let's see here.
Remember my two things that the most favorite things I have to do to solve an equation are get rid of what and what?
Get rid of the variable.
Get rid of denominators.
Oh, that's right, yeah.
Fractions, make it harder. Let's get rid of the fraction. How do I get rid of the fraction?
We would do, just 32 over 1.
No.
Well, we would divide by.
What's the 2?
1/2.
Okay, first of all, it's important to know that what we're looking at is this. Same thing. There's no difference. 1/2 times b squared is the same as b squared over 2.
Okay.
How do I get rid of the 2?
To get rid of the 2, we'll divide, and then the opposite of dividing is multiplying.
Okay, there you go. In other words, first of all, figure out what the 2 is doing.
Yeah.
2 is dividing into b squared, so we have to do the opposite. We have to multiply both sides by 2.
Yeah.
Well, if I multiply that side by 2 and I multiply this side by 2, what do I have?
32 times 2,
64.
which would be 64, yeah.
Equals what?
Is equal to just base squared.
Okay. Now, how do I solve this?
We would find the square root of 64.
Okay.
And then that would get us 8, square root of 2.
Hold on.
8 is equal to b, yeah.
We're taking
There we go.
we're taking the square root of both sides. When I do that, I actually get plus or minus 8 equals b. But since we're dealing with a triangle where I can't have negative dimensions, I'm going to dispense with the negative, and b is equal to 8. So we now know our triangle. In other words, I know we have a triangle, a right triangle, where that side is 8 and that side is 8. That gives me an area of 32. It's an isosceles right triangle. Now all we have to do is figure out what that is. And this is a skill if you don't have it, you want to develop it fast. This will take you a long ways in geometry.
Okay.
And by that I mean two things. Being able to solve right triangles, no matter what two of the dimensions are.
Yeah.
And another skill is being able to recognize a 45-45 right triangle or a 30-60 right triangle, where even if you have only one of the dimensions, you can fully dimension it.
Okay.
Is this one of those triangles? In other words, we can do this the hard way by using the Pythagorean Theorem.
Yeah, a squared plus b squared is equal to c.
Squared.
Squared, yeah, my bad.
So c is equal to the square root of a squared plus b squared.
Yeah.
Okay, but that's the hard way to do it. There is an easier way. Is this one of those 30, 60, 90 or 45, 45, 90 triangles?
I think this would be 45, 45, 90.
It is.
Okay.
I'm going to put these triangles on here, and every time we have a session, I'm going to ask you to dimension the basic one.
Okay.
Because I want you to memorize it.
Yeah, for sure.
So if this is 45, 45, and this is 30, 60, if this is one of these two triangles, then it is similar to one of them. And it will be very easy to come up with the hypotenuse if we know the dimensions on this. Well, if this is isosceles, it has to be 45, 45.
Yeah.
Focus on this. What are the dimensions of the unit right triangle?
Of the unit right triangle, well, 45, 45, 90.
What are the dimensions of it? Not the angles, the sides.
8, 8.
No. My unit. Unit
I see.
1.
I see what you. Yeah, so it'd be.
So that's always 1.
Yeah.
That's always 1.
Okay.
What's this one?
So if those two are 1, will that have to be.
Go ahead and do it the hard way. I mean, do it using the Pythagorean Theorem, but you're gonna have to learn how to use the Pythagorean Theorem and do this. Those are two skills that we're not getting through Sunday without having you learn. Okay? So this is square root of 2.
Yeah. Oh, okay.
Why is it square root of 2? Because c is equal to the square root of a squared plus b squared. Well, that means it's equal to the square root of 1 plus 1. It's equal to the square root of 2.
Okay.
Now, when I say that's the dimensions of this triangle, that's the dimensions of the unit triangle. But I could also make this 3, 3, and 3 root 2. In other words, it's only the relationships that are important. I don't care if that's a 1 and a 1. In fact, some school systems teach that triangle this way. They teach it square root of 2, square root of 2, and 2.
Okay.
Once you get into trig, they think this is more advantageous because you don't need to rationalize the denominator if you use this. But
Yeah.
it's just a matter of choice. It doesn't matter. All of these relative dimensions
Mm-hmm.
are just that, relative. Okay.
Okay.
The reason I call this my unit right triangle.
Uh-huh.
Pi, come here. Pi. Let me let her in.
Sure.
Come on. Come on in. The reason I call this my unit is because it means that the smallest angle always has a side of 1 opposite it. So
Okay.
what are the dimensions of this one?
The dimensions of that one is 1, 1.
No, they're not. That's not isosceles, so it's not going to be 1, 1.
So it would be 1, 2, square root, or yes, square root of 3, then 2. Okay.
Do the sides first in terms of memorizing. Do the hypotenuse last.
Okay.
Okay, I want you to be able to draw these two triangles from memory from now on.
Okay.
That's part of your homework.
Okay.
Okay? In other words, whenever I say, what are my unit triangles, give me the dimensions of them. And here's the reason it's so important, is now I'm looking at a similar triangle. This triangle is similar to this. What's the similarity ratio?
Like for this one, surface to area ratio is...
Not surface to area. The similarity ratio means the similar side relative to this similar side.
Okay. So this one would be 4 to 1.
Where are you getting 4 to 1?
Well, it's 8 to 1.
That's what it is, 8 to 1.
Oh, it's just 8 to 1. Okay. You don't have to simplify it?
There's no simplifying. It's 8 to 1. In other words, what I'm comparing is that with that.
Okay.
Those are corresponding sides of similar triangles.
Yeah.
Okay. Once I figure out what that proportion is, then I know the proportions of every other side. If this is 8 to 1, this has to be 8 to 1. So, the hypotenuse.
Okay, so for... Okay, so... Would it be the just square root of like 64 for that one? Because it's like...
When you multiply a whole number by a square root number, you don't multiply it on the inside.
On the outside.
Yeah, so this is 8 root 2.
8 root 2, okay.
In other words, this number is 8 times bigger than that number.
Okay.
Don't put the 8 on the inside and take the square root of 16. Not if multiply. Okay, that's all we're talking about, is we want to make sure that every side of this triangle is 8 times as big as every side of this triangle. Because they're similar, and because they have a similarity ratio of 8 to 1. Okay? That's why it's important to know all 3 dimensions on this one and this one.
Yeah.
Because of that. So the answer to our problem here is 8 root 2.
Okay.
Now I'm not going to leave this yet.
Okay.
I want to do some more of these because this is so important. So I'm going to give you triangles. And I'm going to give you only the fact that it's a 30-60 right triangle.
Okay.
And this side is 3. Tell me what x is. I purposely did not orient it the same way.
Yeah. Okay, so we don't know.
So what's the first
right side?
Figure out always.
The other side.
No,
not x, but the other side.
This must not be a term they use in your geometry class.
No.
I have had many geometry classes that use that term, and that's my favorite term.
Okay.
Your class maybe called it the linear ratio. or R sub L.
Okay.
Okay, but it's the same thing. In other words,
Yeah.
it is a measurement of a linear number versus another linear number. We're not comparing areas. I'm not comparing the area of this triangle with the area of this triangle. Because all I'm trying to do is figure out what is the linear ratio.
Okay.
So I have to find the corresponding sides. In other words, I have to know what's the corresponding side to that.
The corresponding sides, that would be...
This triangle, which side is the same as this side is up here?
The bottom.
I don't mean the same number. I mean, what's the corresponding side? When you have similar triangles, every side has a corresponding side in the other triangle.
Yeah.
So what is it in this one?
1.
Correct. In other words, what we do to figure it out is we look at the angle that's opposite it. The 3 is opposite the 30-degree angle. So we're looking for the side opposite the 30-degree angle. Well, that's this one. What's our similarity ratio here?
3 to 1.
Okay. And now, what is x?
So if it's 3 to 1, then x would be, let's see here. Wouldn't it be 3 square root 1?
No, we have to find the corresponding side on that other triangle that corresponds to the hypotenuse.
So the corresponding side for that would be 2.
Okay, so what's x?
2.
What's the similarity ratio between these two triangles?
3 to 1.
Means every side on this triangle has to be 3 times its corresponding side on this triangle.
So it's 3 square root 2.
No. It's 3 times 2.
Just 3 times 2? Okay.
You see why?
In
other words, once I've figured out that the similarity ratio is 3 to 1, and I do that based entirely on this side versus this side, well, now I know that every single side has to be 3 times bigger than this triangle. Well, we're talking a hypotenuse. There's only one hypotenuse here. There's only one hypotenuse here. They must be corresponding sides.
Yeah.
So this side has to be 3 times bigger than that side.
Okay, so it'd be 3 times 2. Okay.
Now, what's this side?
And then that side would be square root 3.
That would make it the same.
So it's 3 times the surface ratio. So it would be
3 times square root of 3.
Okay.
In other words, it's 3 times bigger than this. And it's not surface ratio.
No.
It's similarity ratio. And the word is important only because it only refers to similar triangles.
Yeah.
It doesn't have anything to do with surface area. It has to do with similar triangles, and that's why the term is used. Now, you may end up using something like that in class. That would be the linear ratio, because you also study area ratios and you also study volume ratios. So I know that this is the way they taught it in Balzac's class, or what's it?
Yansack, yeah.
Yansack class. But if you're talking about the differences between a linear ratio, an area ratio, and a volume ratio, this is a nice little model here. Because if the linear ratio is 3, the area ratio is 9, and the volume ratio is 27.
Yeah, exactly.
If you're comparing linear ratios to area ratios, you want to use this model here because you know all of that. But
that's what we've been using in class. Is
okay, so let's call this thing R sub L.
Okay.
We're not going to deal with area ratio or volume ratio in this problem. The only thing we're dealing with is that linear ratio.
Okay.
Okay, and so I call it SR.
Okay.
But they mean the same thing. And we're not leaving this till you get it.
Yeah.
I'm going to draw some more similar. I'm going to draw some triangles that are similar to these two triangles. And
Okay.
I'll ask you to dimension them for me.
Okay.
What are the other two sides?
Okay. So if that's 4, uh, so let's look at the bottom.
The first thing you need to figure out.
Yeah, so the first thing we need to figure out is
Okay,
R of L.
call it that.
Yeah.
R of L.
Okay.
What is R of L?
And then the R of L would be 1.
What are you comparing
Oh.
with that?
Let's
You
see.
can only compare corresponding sides. I cannot compare the 4 to the 1. The 4
No,
is
so
the
we have to.
hypotenuse, the 1 is the shortest side. So you have to always be, in order to come up with R sub L, you have to make sure you're comparing it with the proper side. That's why
Yeah.
you need to know all three of these dimensions.
Okay.
And you need
So
to know all
the.
three of those dimensions.
Yeah.
Otherwise, you won't be able to do the problems.
Okay. So the R of L would be 4 to 2, so it'd just be 2.
Okay. So
Okay.
now, what is this x?
That X would be 2.
Good. And what is this x?
And then that X would be 2 times, or wouldn't that be 2 square root of 3?
Good.
Okay.
You're getting it.
Yeah.
All you need to do.
Okay.
Okay, we're not leaving it yet, though,
No. Yeah.
because they can get a little bit harder.
Okay.
Not a lot. Not if you use the same methodology, they won't be any harder.
Okay.
But what are the two short sides?
Okay. So the R to L ratio, or R to L would be, how would we combine those two, 4 to 2, and then square root of 2?
By
4 square root of
always
4. Okay.
That's the process we use to come up with R sub L.
Okay.
What is that number equal to?
Just 4 to 2.
Not 4 to 2.
4 to square root of 2. Oh, so it'd just be 4.
4 to 1. 4
to 1, yeah.
In other words, our linear ratio is 4.
Okay.
So what's this side and what's this side?
Alright, so if that's 4 to 2.
Not 4 to 2, 4 to 1.
Or 4 to 1, my bad. So if that's 4 to 1, the bottom would be 4. And then this side would also be 4.
Okay.
Yeah.
All right. So now we're going to step it up a notch because this is where it gets harder. Hold on.
Okay.
But not really. Not if you use exactly the same scenario.
Okay.
Now, what is the L sub R?
Length. Okay. So for this one, it would be 3 to the square root of 2.
Okay, good. Just use exactly the same process.
Yeah.
And now, how do I figure out what that is?
We do 3 over the square root of 2 times 1.
Perfect. So
Okay.
this is 3 over root 2. This is the same thing. But
Yeah.
there's a problem with that answer. What is it?
It's not simplified.
Right. So how do we simplify this?
Well,
How do you
we could
rationalize?
just cancel out.
No, how do you rationalize an irrational denominator?
You you put it into like a rational
No, you got to multiply top and bottom by
by
whatever
2.
that irrational, by square root of 2.
Yeah.
In other words, this is the number 1. Any number divided by itself is 1. And I
Yeah.
can multiply any fraction I want by the number 1 without changing its value.
Okay.
Okay? So this turns into 3 root 2 in the top and 2 in the bottom. So that's actually the answer is is 3 root 2 over 2, which is the same as what we had. It's just expressed properly. In other words, that's the same number as that. It's just we can't write it like that. We have to write it like this.
Okay.
Okay, so just because one of our sides was a whole number and the other was an irrational number, that's as tough as it gets in terms of doing the arithmetic, but it's no different. It's there's no problems with that. So let's stay on that theme.
Okay.
For the next 3 minutes.
Cool.
And I'm going to make this 30, that's 60, and I'm going to make this square root of 5.
Okay. So we know the R to L would be square root of 5 to 2. And then
this side?
that side would be just square root of 5 over 2.
Okay.
And then the bottom would be just 15 over 2.
We're multiplying this by that, right?
Yeah. So what do we do?
What is, when I multiply square root of 5 times the square root of 3, what do I get?
The square root of 15 over 2.
Okay, that's the answer.
Okay.
Okay? In other words, at a minimum, you have to know how to multiply these things.
Yeah.
How to multiply a number times a radical and 2 radicals. In other words, the principle here is if I have the square root of a times the square root of b, that's the same as the square root of a times b.
Okay.
Okay? And if I have, 3 times the square root of b, that's the same as 3 times square root of b.
Okay.
So, okay.
Awesome.
That's a good spot to get to. We only have a couple of pages, I think, that we did, maybe 3. So your homework won't be very much. Just still do the odds, and we even did one of the odds. So
awesome. Yeah.
I'll send that. And that email address I sent it to, did that get to you?
I did get that, yeah.
Okay, good. I got it.
Yeah, so that'll work.
I got it in there right then.
Awesome.
So, all right.
Awesome.
Dylan, I will talk to you at 11 on Sunday.
That sounds good.
Okay.
All right, thank you.
Have a good one. Bye-bye.
You too, bye.